Why does atmospheric pressure influence condensation? Imagine standing outside on a humid day and watching the fog roll in, or seeing dew form on grass in the early morning. Have you ever wondered what causes these water droplets to appear? Well, it all comes down to the relationship between atmospheric pressure and condensation. Atmospheric pressure is the force exerted by air molecules pushing down on everything around us. It plays a big role in how air behaves, especially when it comes to water vapor. When air rises to higher altitudes, the pressure drops because there are fewer air molecules pushing down. This lower pressure allows the air to expand and cool down naturally. Now, cooling air is a key part of condensation. When air cools to its dew point, the temperature where it becomes saturated with water vapor, water begins to change from vapor into liquid droplets. This is what we see as dew, fog, or clouds. So, when atmospheric pressure decreases, the air expands and cools, making it easier for water vapor to turn into liquid. Think of it like this. At lower pressure, the air can't hold as much water vapor. As it cools, it reaches a point where it can't keep all that moisture and vapor from anymore. The excess water vapor then condenses onto tiny particles in the air called condensation nuclei, forming droplets. These particles act like tiny surfaces for water to cling to, helping clouds and fog develop. On the other hand, when air sinks and pressure increases, the air compresses and warms up. This warming raises the dew point, making it less likely for water vapor to condense. That's why you often see clear skies after rain or in the afternoon when the air is warmer and under higher pressure. Understanding this process is important in weather forecasting and climate science. It explains why clouds form when air rises and cools, and why fog appears close to the ground. It also helps in designing systems like air conditioning and refrigeration, where controlling pressure and temperature is essential. So, in simple terms, atmospheric pressure influences condensation because it controls how much the air expands or compresses. When pressure drops, cooling occurs, and water vapor turns into liquid. When pressure rises, warming happens, and vapor stays in gaseous form. This constant dance between pressure, temperature, and moisture shapes much of the weather we see every day.